Hi everyone, my name's Adrian. I'm from Sigma Prime, which among other things is building an Ethereum 2.0 client in Rust called Lighthouse. So the talk that I want to give today is titled The Anatomy of an Ethereum 2.0 Client, which some of you may know as to be a little bit ambiguous because there's not just one Ethereum 2.0 client, there's many. In fact, there's all of these ones. So Lighthouse is the client that I'm working on. It's a Rust-based one, and it's because I'm working on it, it's the one that I'm most familiar with, but there's many others. There's Shaspa, which is another Rust client maintained by Parity. There's Trinity, which is written in Python. There's Harmony, which is written in Java. Artemis is also in Java. I believe those two clients are going to be merging into one. There's Lodestar, which is written in JavaScript. Prism, written in Go, and Nimbus is written in Nim. So as you can see, there's quite a range of Ethereum 2.0 clients. And so what I'm going to try to do in this talk is not specifically talk about one, but more about all of them in general, roughly how they work, what's their internals, and I'll try and be as general and abstract as I can. Some parts of this are Lighthouse specific because that's the one that I work in with some of the examples, but I will try and be as generic as I can. So another thing to note is that all of these clients are written by individual teams over a range of different programming languages. So they are fundamentally different, even though they're implementing the same specification. Okay, so the structure of this talk. I've split it up into three main sections, and the three sections are designed to try and give information to a wide range of audience. So the first section that I want to talk about is for people that are interested in participating in Ethereum 2, that is the end users. So if you're sitting here today and you've got some Ethereum and you're trying to figure out, I want to get more Ethereum and I want to contribute to Ethereum 2.0, then this part is for you. This is a very high-level overview of what you need to do to be able to participate in Ethereum 2, how to use the clients, and essentially, make more Ethereum on Ethereum 2. The second section of this talk is more focused towards students and developers. So this is people that are interested in the underlying technology. So I'll be talking about like the client architecture, some of the core technologies. And in the spirit of yesterday's panel, if there's any students or developers that are interested in anything that I talk about, pretty much everything that I talk about is under research and development, and we always want extra help. So feel free to chat with me afterwards. The third section of the talk is going to be kind of focused towards more commercial users. Towards more commercial users, and I'll be focusing on some of the APIs that is associated with Ethereum 2.0 clients. So that is how, if you're building applications on top of Ethereum 2, or if you want to, how do you actually connect to these clients? So these are the APIs that do that. Okay, so let me begin with the end users. So in Ethereum 2.0, there's where we're transitioning to proof of stake. So in Ethereum 1, we have miners. So the miners, produce proof of work, or they do proof of work and contribute to the system. As a response, they get as a result, they get a reward for doing this. In Ethereum 2, we have proof of stake, which means you have to contribute some stake and perform some actions on the ecosystem in order to get rewarded. So the analog of a miner in Ethereum 2 is a validator. So you need to be a validator in order to participate in the system. And by being a validator, you'll be rewarded for contributing to the system. So I just want to briefly go over the validator lifecycle, so what you have to do to participate in Ethereum 2. And this is a very high-level overview. If you want a more in-depth discussion of the validator lifecycle, I recommend looking at Xiaowei's slides, who spent a bit of time, and a lot more detail in the validator lifecycle. So anyway, to begin with, the first thing you need to do is you need to generate keys. So key generation is the first step to become a validator. In Ethereum 2, we're using the BLS signature scheme, which is different to Ethereum 1. In Ethereum 1, we use SCEP 256K1. So what that means is you can't use your Ethereum 1 keys in Ethereum 2. You need a new set of keys. And you need to generate 2 keys, not just one. So the 2 keys that you need are a validator signing key and a withdrawal key. We have 2 separate keys because as a validator, when you're participating on the ecosystem, you need to do constant signing. And so that means you'll be using a key quite regularly. So if that gets stolen or your software gets hacked, they can't immediately withdraw all of your stake, right? So the withdrawal key is something you keep separate, and that is the key that you need to withdraw your stake from the system. Once you've done key generation, you need to then deposit some original Ethereum 1 into a deposit address on the Ethereum 1 chain, and you need to supply your validator key and a hash of your withdrawal key, and you provide a signature proving the ownership of the validator key. The signature is required because there's a cryptographic attack in signature aggregation in BLS called the rogue public key attack, if you're interested. But this is just one way of mitigating that. So these are the main things you need to contribute to the Ethereum 1 deposit address to become a validator. Once you've done that deposit, you've deposited your 32 ETH, you then need to wait a period of time. The waiting time is essentially some time for the Ethereum 2 chain to recognize your deposit. You get put into a queue, and then after a period of time, you become activated. Once you're activated as a validator, you then have to actually run some Ethereum 2 clients. So to participate in Ethereum 2 and get rewarded for your stake, you need to do active contributions, and what that means is that you need to be running an Ethereum 2 client. More specifically, you need to run a validator client and a beacon node, and I'll talk about the differences between those two things. But fundamentally, what you're participating in the system, you're voting on shards and you're voting on blocks. At a network layer, what the software actually produces are things called, you produce blocks and you produce attestations. So this is your contribution to Ethereum 2, and by doing so, you get rewarded with more Ethereum. Provided you don't modify the client and misbehave, then you will get not rewarded, or the opposite of rewarded. You will lose money. So after a period of time, you can, if you don't want to be a validator anymore, or you've decided you don't want to run the client, you can exit. You don't have to be a validator forever. There is a number of ways you can exit from being a validator in the Ethereum 2 system. The first one is a voluntary exit, so you can opt out. When you opt out, you're no longer a validator. You can get removed due to excess penalties. So if you are inactive for a long period of time, your balance will slowly decrease until it reaches a threshold. At that point, you will get ejected from being a validator because you don't have enough stake in the system anymore. And the third one is being slashed. So if you have done something bad or you've modified the software to try and do something a little bit malicious, you can be slashed. What that means is that you've done something that breaks the rules of the system, and we immediately eject you. You get kicked out. So this is roughly what you need to do to be a validator in Ethereum 2, and how you can participate. So I just want to give you a very high-level overview of how you use the software to do all of these things. So the first thing I should mention, so this is in the section of generating a key and putting Ethereum 2 into the deposit address, is staking pools. So staking pools are similar to mining pools in Ethereum 1, which allows you to just send Ethereum to essentially a staking pool. You don't have to send the requisite 32 ETH. You can send less than that, and the staking pools will pull that together. They manage a whole network of beacon nodes, beacon validations. They control the software for you, and they will pretty much do all of the heavy lifting and hard work. And in return, you will receive some stake as you earn it. So the benefits of staking pools is that you don't need to manage the validator keys yourself. They generate the keys. They'll interact with the deposit address. You don't need to manage any of the beacon nodes or validator clients. You don't need to manage the software. You don't need to interact with the deposit contract. You don't need to stake multiples of 32 ETH. You can do less. And these things are typically UI focused. So one example is Rocket Pool, which I've got here, which is a screenshot from their beta program. This pretty much abstracts a lot of the work of running Ethereum 2 clients, but it's an easy way to participate and join the system. So I figured I would mention this. So if you're not going to join a staking pool and you want to participate yourself, you're going to have to do the steps that I mentioned earlier manually, generate keys and interact with the deposit address. So from a client perspective, currently I think most clients are interacting. This is small and not too dark. It's slightly dark, but the idea is currently we have CLIs, command line interface tooling, that allows you to run a single command to generate some validator keys. As we move closer towards mainnet, I think all of the client teams will be focusing more towards UI things, so that you'll be able to just click and point to generate a key. But currently, if you want to try and test these things out, I think all of the clients, this is an example of Lighthouse. If you want to figure out how to use our CLI, we have documentation. But you can essentially run a single command which will generate a validated key for you. I think we'll update this so that it also helps with interacting with the deposit address. So after you've run your single command and you've generated a key and you've deposited onto the deposit address in Ethereum 1, you need to then run a beacon node and a validator client. So each participant has to run a beacon node and a validator client. The beacon node, I haven't quite talked about this yet, but the beacon node is the main piece of software similar to Geth or Parity in Ethereum 1. It has all of the core logic, I guess. The validator client is kind of you can think of it as like a hardware wallet. It manages the keys and does the signing, and it's separate from the beacon node. There currently, at the moment, is some development going to around UI that wraps these Ethereum 2 clients. One example is Mitchmatic, which is working with Prism. And here are some 2 screenshots that they have of this UI. So the idea is that you have a UI that wraps the beacon node. You can click on it, create a validator. You can see other validators on the network. You know what your balance is. You know how much is coming. And it gives you a state of the current state of the network. So again, as we move towards phase 0, there will be more and more work going on towards building UI-focused Ethereum 2 clients. But at the moment, you can still run everything from the command line. So again, an example of running Ethereum 2 from the command line is with Lighthouse. So with Lighthouse, you can run a single command. That's the top window is a beacon node. The bottom window is a validator client. The validator client automatically connects to the beacon node and does its duties. I think Danny Ryan calls those duties. But this is essentially an example of how to run a beacon node and a validator client. Once you have this on the mainnet, you just let it go. You sit there, and you should accumulate rewards for participating in the network. Okay, so that hopefully is a high-level overview of how you could participate using Ethereum 2 clients on the network. I now want to focus a little bit more on the core technology, some of the technologies that we've decided that underpin these Ethereum 2 clients. So hopefully, if there's any students or developers that are interested, this section pretty much has everything that's under research and development. So let me begin with client architectures. So I'm pretty sure all Ethereum 2 clients have segregated validator client from a beacon node. And as I was saying, a beacon node contains the core logic similar to Geth or Parity in Ethereum 1. In particular, it has the state transition logic. It has its own database. It is the thing that contains the network stack, so it interacts with other peers on the network. And it has an RPC server or HTTP RPC server to interact with other applications on top of it. So this is the main piece of software that allows you to interact and participate in the Ethereum 2 network. If you're going to be a validator, then you also need to run the separate piece of software called a validator client. So the validator client manages your keys. You don't need to have one validator client per key. You can put multiple keys into this piece of software, and it will look after all of your validator keys for you. And it keeps track of the task that the validator is required to do. So when you need to propose a block, when you need to do an attestation, the validator client will keep track of that and perform the signing when it needs to. It also should, depending on the client infrastructures, as I said, there's a number of different teams building each of these pieces of software, so they're going to be different across different implementations. But they should have inbuilt slashing mechanisms, which means it keeps track of what you've signed before so that you don't accidentally make a bad signature and then lose all of your stake. So this should have a preventive mechanism inside of it to stop you from accidentally performing bad signatures on the network. Okay, so more specifically in the validator client, fundamentally the way that it works is it connects to a beacon node. It checks for specific tasks from the beacon node. So given its set of validator private keys that you've given it, it knows about all the validators that it needs to perform tasks for. It asks the beacon node, given all of these validators, when am I supposed to propose a block or perform an attestation? When that time comes, then the validator client can ask the beacon node to either give me a block that I'm supposed to sign or give me an attestation. It will perform the signing and it will send it back. Some important things that you should note is that the idea is that the validator clients and the beacon node are, even though they're built across a number of different client implementations, that the communication between them is standardized. So what that means is that if if you have a favorite beacon node client, you can use, and a favorite validator client, which is written by two different companies or two different languages, they should be cross-compatible. So you can have a Lighthouse validator client connected to a Nimbus beacon node if you prefer. You can also have a validator client connected to many beacon nodes for redundancy. So if one of those goes down, you don't want to actually start losing money, so you can have backup beacon nodes. Okay, so a little bit more in depth into the beacon node, some of the core components that we have. Fundamentally, it looks, a beacon node looks very similar to a standard blockchain client that you would expect. It has a HTTP API that allows you external applications to connect to it. It has state execution and syncing logic, so when you get a block, how to transition from one state to the next, and it has its own internal networking. The networking is significantly different from Ethereum 1 that warrants a little bit more detail in this slide. So in Ethereum 2, as Raul's spoken about, we're using libp2p. In particular, we're using these protocols here in libp2p. The first one is gossip sub, which is pub sub. Raul quickly went over this. We're using this protocol to propagate blocks across the network. So this is an epidemic kind of protocol, which allows us, when we get a block, we propagate to the network, it propagates to all the other peers and gets sent across the network. We have a custom protocol called ETH2 request response. This is a direct peer-to-peer communication protocol, like an RPC. So when a new peer joins on our network and we find that they have potentially a lot more blocks than us, we want to sync with them, we use these protocols to perform syncing to download blocks immediately from them. We're using Discovery v5, which is an upgrade of Discovery v4, as you can imagine from the name. It's fundamentally a modified Kademlia that works under UDP, and it's currently in development. I have an extra box here which has extra protocols. Because libp2p is modular, it allows you to add and remove protocols, and different clients and different teams can add their own protocols that allow their clients to interact and talk to each other. One example is libp2p offers a protocol called Identify, which allows you to acknowledge or find out that, what protocols your peer supports, the version it's using, and among other things. So different client implementations can actually introduce and use different protocols, and you will see that when we hit mainnet, I imagine. Yeah. Okay, so everything that I've talked about so far, actually, everything even on this slide is still under development. As Raul said, Gossip Sub is kind of transitioning. They're trying to build a new one called EpiSub. So the first protocol's under development. Discovery v5 has only just kind of been specified. There's still a little bit more specifications going on. So everything here, if you're interested in networking or some of the state execution, this is all still under development and some research and development. So the next thing is everything that I've spoken about so far is kind of general across all Ethereum 2 clients. So now I want to talk about some of the discrepancies that you might be interested in across the clients. So we have an Ethereum 2 specification, and that tells us roughly how the rules about how the system should work, but it doesn't tell you about how you should implement them. A simple example is that there's no optimizations really in the Ethereum 2 specification. So the implementers and the client teams will find their own implementations, and you'll have different performance trade-offs for memory, speed, or size. So some clients that are trying to build an Ethereum 2 client that goes on a very small embedded device might make decisions that optimize on size, but has a trade-off versus time. So different client implementations will have these kinds of trade-offs. So I just want to, even though there's a whole heap of these, I just want to talk about 4 major components that you might see differences between Ethereum 2 clients. The first one is the database. So straight off the bat, Ethereum 2 clients can have different database types. The layout of databases will be different, which will also affect the optimizations, whether people favor speed on read or write access. So there's a number of different optimizations that are going to happen in the database alone. So the next one is syncing. We have a networking specification that tells us how we can download blocks and state from our peers, and it implies a general form of syncing strategy, but the implementations, there are different optimizations and different strategies that in some cases can be faster and in some cases can be slower depending on the state of the chain and the network. You can have optimization guesses, which if they don't work out can be slower. So different syncing strategies you'll likely see across different clients. And the way that we do peer load balancing, so if we want to download blocks from 100 different peers, that's also subjective. So different clients will have different syncing strategies, I imagine. The next interesting one, especially for people that are doing this to make profit, which I imagine everyone, which is the fundamental incentive, is attestation selection strategies. So in Ethereum 1, where if you're a miner and you're getting transactions, you get a lot of transactions, so many transactions that you can't fit them all into a block. How do you decide which transactions do you put in your block? In Ethereum 1, it's easy because we want to maximize the amount of money we make when we solve this block. So what we do is we just choose the Ethereum transaction that has the highest gas price, and we order them, and then any ones that the lowest ones we just remove from the block. In Ethereum 2, it's not so obvious. We can't do that same strategy. It's not obvious which ones that you add into the block that you have will maximize your profit. So there's a number of different attestation inclusion strategies that different clients can take. Ideally, you want to maximize your profit, but there are going to be inherent trade-offs in which strategy you use. So you might find you will make a different amount of money depending on your client implementations, in principle, in theory. Fork choice. So fork choice, we have an algorithm so that if a chain forks or diverges, we need to run an algorithm to determine given our subjective view of the current state of the blockchain, which one is the longest, which is the canonical chain. The specification has a fork choice in it, which is prohibitively slow, so none of the Ethereum 2 clients should use it. They need to use an optimization of the original specification. And there's a range of these different potential algorithms that clients can use. Some of them have different trade-offs as well. Pretty much everything I'm talking about here has some trade-offs, so implementations, depending on what they're focusing on, will take one trade-off over another. So you might find that different clients are faster in some regards and slower in others. Another thing I should mention is most Ethereum 2 clients have their own metrics internally built. I think most of the implementers at the moment have these built in mainly for profiling, testing performance, and just looking at the current state of the network. Lighthouse has a Docker if you're interested in running this thing, and it gives you, this thing spins up 4 nodes and looks at how those 4 nodes work on the network. But this is kind of interesting if you want to play and decide which client kind of works for you. You can run separate clients, look at their metrics. So ours, and I'm pretty sure a lot of the others, gives out information such as database read writes, how many resources are being used, some of the networking statistics. So you can, depending on your use case and which Ethereum 2 client to use, you can look at some of the metrics that they have built in, which is another interesting fact. So the last part of this talk, I just really briefly want to go over commercial users and developers. So this is just specifically the data model and the APIs that we're planning on using for Ethereum 2. So if you're a big data scraper or an exchange and you want to interact with Ethereum 2, you're going to need to interact with one of these clients and typically through one of these APIs. So the first API I want to talk about is the Validator Client to Beacon Node API. So this is we're trying to standardize this API so that, as I was mentioning earlier, that you can have a range of different validator clients from a number of different teams interact with a range of different beacon nodes from a number of different teams. So you can have one validated client from one team interact with a beacon node from a number of other teams. So by doing this, yeah, you can clients can connect to arbitrary beacon nodes, and it also works the other way around. You can use a variety of beacon nodes as backups. So if one client has a very catastrophic bug such that all of those type of clients go down, you can have a backup of a different kind, and you can continue running on the network without losing any stake. So this repository up here, the Ethereum APIs repository, is currently, currently under development. This is a screenshot from the validated client to beacon node API, which pretty much outlines what we're currently thinking of using as the API between those two things. So if you're interested in building your own validator client because you want to add extra features, or if you want to make any kind of self-improvements, then this is the API that you should conform to. This will allow you to connect to most of the Ethereum 2 beacon nodes. The next API is the beacon node API. So this is, you can think of this as like the JSON RPC API of Geth or parity. We want to standardize this as well across all of the clients so that you can build applications on top, and the underlying client that pins the applications, it doesn't matter which implementation does this. The current plan is to use a HTTP API. This is from lessons learned from Ethereum 1. And the other important thing is that this is currently under discussion. We haven't specified or come to agreement on exactly what this HTTP API should look like. So I saw in Mel's talk yesterday from Monolith, he said that they had to rewrite the JSON RPC for Geth because it wasn't sufficient. So I encourage anyone that's looking at building the applications on this on Ethereum 2 to get involved in these discussions, because we can modify this now before we all start kind of programming this. So there's a pull request for this rough HTTP API up on the top right there. Prismatic Labs also have a version as well. So we need to kind of standardize the beacon node HTTP API. And that's it. That's hopefully an overview of some of the Ethereum 2 clients and what's being worked. So thank you for your time.
Thank you. That's an awesome sharing. And do we have any questions from the audience? Raise your hand if you have any questions. Mel, you look like you have a question to ask. I'll speak afterwards. Okay.
Maybe someone want to know what's your question. So it's okay.
You sure?
Okay.
Okay. Anyone else? Is there anything? I think so. Okay. Very good. Okay, great. 让我们再次感谢我们 Adrian. Thanks again.